Hello and welcome. Today we're going to learn about the powers of I. I is a complex number, imaginary number. It's equal to the square root of -1. It's a nice, easy shorthand to deal with square roots of negative, which are normally not allowed. But they give certain patterns that are useful in the real world, and so we deal with them. So when we see powers of I, the easiest power is the square. Now, we can take the square of both sides, like so. And when we do such, what we get is the following. The left side becomes I squared. And the right side, the square and the square root cancel, leaving you with just a -1. Now, the next power of I that's relevant is going to be I cubed. And the way we're going to deal with this and understand it is to multiply I to both sides. If we were to multiply to I to both sides, then on the left side, what we're going to get is if we add I to the 1 times I squared and add those exponents, we get I to the third power. And on the right side, we just get a -I. Nice and easy. Now, we're going to get I to the fourth by once again multiplying by I on both sides. So when I do that, I on the left times I on the right, I get the following. On the left side, I get I to the fourth power. And on the right side, I get that it is equal to -I squared. Now, we actually saw I squared before, so we know it's a -1 up here. And what are we going to do with that information? Well, what we're going to do is reduce this. Instead of I squared, I'm simply going to write a -1. And when I do that, what I get is a -1. Notice it's not -1 squared. It's entirely replacing this. And so I squared itself becomes just -1. And then that becomes, in the end, a +1. So our pattern looks like the following. I is equal to square root of -1. I squared is equal to -1. I to the third power is equal to a -I. And I to the fourth power is equal to a +1. Those four are going to be very important. Now the question is, well, do we just keep doing this forever, right? What if they ask about to the 13th or the 17th power and so on? Well, what we're going to see is there's a pattern. That pattern is going to look like this. If I go and I try and make an I to the 5th, that's actually going to be, because I just multiply I on the left side and the right side of this equation, that's going to be I to the 5th is equal to I. And that looks a little familiar. I to the 6th, if we once again multiply on I on the left and right side, I'm going to get an I squared, also known as a -1. I to the 7th, if we follow this pattern, it's going to be a -I. And then I to the 8th is going to be a +1. We can just keep following this pattern. So the key to this is to look at the base 4. These 4 powers of I are all that can possibly exist in a simplified form. So how do we actually reduce these large complex numbers? Well, the pattern is that every 4 repeats. So I can take any number, find multiples of 4 in the exponent, and reduce it. So let me give a couple examples. So first off, if I have I to the power of 15, what am I going to do? I'm going to try and say, how many times can I get 4 into there? And it's okay if you're not sure at the start. Well, I know 12 fits into there. So maybe I to the 12 times I to the third, because 12 plus 3 is 15. And well, I to the 12th, that's a multiple of 4. And I know that any multiple of 4 is just going to go away. It's going to turn into a 1 times I to the third power. And because of that, I now have something that's similar to these base 4 that I have to memorize. And that number is the I to the 3. And now I'm going to further reduce to my base power of -I. And that's because I referenced this known memorized I cubed. And I know that it is in fact just a -I over here. Let's try another, maybe bigger and scarier. Let's try I to the power of 37. I to the power of 37. What is that going to equal? Well, once again, I got to think of multiples of 4. I don't know, maybe I know that there's a 20, right? 20 is pretty easy. So I'll do I to the 20 times I to the 17. And you can, if you have a better, closer guess for a multiple of 4, you can go straight to it. But I'm going to do I to the 20. And the I to 20 just goes away. So this is I to the 17. And I think we can reduce it more. So I think about more multiples of 4. Let's try 16. So this is I to the 16 times I to the first power, which I'm just going to leave as I. And this becomes just an I, and that's our answer. That's a fully simplified I to the 37th. So even though this is a large intimidating number, I just keep looking for multiples of 4 and kind of chopping them off, getting rid of them. Let's try one more. So we're going to have I to the power of 26, I to the power of 26. And when I find multiples of 4, again, an easy one is 20, so I'll just go I to the 20 times I to the 6th. Oh, I to the 20 goes away. All multiples of 4 go away. This becomes I to the 6th. I can do more. I can reduce it more. Oh, well, it's just I to the 4th times I squared. I to the 4th goes away because it's just a 1. We're left with I squared. Now, again, I'm not going to leave my answer as I squared. I can only really leave my answer in terms of 1 or regular I. No powers of I at all, in fact. And so I reference my memorized quantity of what the heck is an I squared. Well, according to this, it's a -1. So I'm going to say this is equal to -1. And that's my final answer. So it doesn't matter how ugly this number over here is, keep chopping away at it by finding multiples of 4, and it makes the problem much easier and lets you reduce step by step by step.